We are lucky because we have two more interviews, and these are with stars, rising stars of the Smithsonian programs. First, Doctor, would you come out? Dr. Jennifer Nagashima, Smithsonian Institution postdoctoral fellow for the Smithsonian Conservation Biology Institute. Hi. You can have a seat right over here. Violating my rule never to appear with babies and dogs. We try to overlook the obvious. Mike Trizna, would you come out, please? Trizna. He is the technical lead for the DNA Barcode of Wildlife project, managed by the Smithsonian Barcode Network. So Jennifer, tell us why Cannon is so unusual.
Well, Cannon's special in a couple different ways. First of all, he is one of the first puppies born in the world by in vitro fertilization. So he's a test tube puppy. He and his siblings, we took an egg and a sperm and put it together in an incubator and produced Cannon. And he's also really special because he actually represents a partnership between Smithsonian Institution and Cornell University trying to solve issues facing conservation of endangered canids.
And what makes him really good, he doesn't urinate or defecate.
I wish. We're doing blatant bribery right now.
So what does this lead to?
So we're hoping to now take this technology we've developed, it's was 40 years in the making by researchers, to now apply it to endangered canid species. So for example, red wolves or African wild dogs.
I was with your team when they went to Kruger.
Yes.
And collecting semen from elephants to freeze it.
Yes.
And then bring it back here and artificially inseminate. So we don't have to transport, a 1,000-ton animal. How far along are we since I did that documentary?
Yeah, it depends on the species. So for dogs, or canid species, we have some good techniques depending on the species for freezing the sperm and transporting it across even continents. For eggs, we are still working on that. It's a little more complicated. The dog eggs are actually full of lipids, so they don't freeze very well. But for embryos, we're able to do it. So he was actually also a cryopreserved embryo. So whenever he does something silly, I'm like, well, you were frozen. They're not laughing at you. They're not laughing at you.
That's right. He likes to laugh. He gets nervous when we start talking about those things.
He's wondering what's
Mike, the Barcode project. Now, is that, so if you want to buy an endangered species, all you do is pass the barcode through the cash register?
Sort of like that. So the barcode's a metaphor for being able to sequence just a small snippet of the whole genome to identify an unknown sample. So the whole human genome is 3 billion base pairs long, the A, G, T's, and C's. But the barcode for animals is just 650 base pairs long. So it's very easy to sequence, and you can reliably tell what an unknown sample is.
How much more do you have to do?
So the Barcode of Wildlife project, which we started, kind of targeted endangered species. Dan, Jansen, and Winnie, they've barcoded tens of thousands of butterflies in Costa Rica and Guanacaste. So if you came across an unknown butterfly from Costa Rica, you could very easily tell what it is by sequencing it. But you don't have that kind of coverage for endangered species. So that's what the Barcode of Wildlife project was for, was to fill in those gaps to make sure that if you have an unknown sample from a protected species, you would find a good match for it when you sequence it.
Filling in the gaps is a good phrase. The first question I think I ask of one of my scientists as a new explorer in the Amazon is, why do you do this? And you don't have to answer. He said, well, can I think about that all night? So the next morning I said, why do you do this? And he said, because it adds one more little piece of information about how the world works. And I thought that came as close as anything. Thank you, too, and congratulations
you so
for being stellar. All right.
Thank you.
Thank you, Canon.